So in this video, we're going to talk about a topic called structures or structs. And the best way of describing this, in my opinion, is to give an example, okay? And so we're going to start with an example that we're not using structures. And we'll see how by trying to do this without using structures, it can get very complicated and can be very confusing. And then we'll see how we can simplify it, which is the motivation for our kind of current topic in this video. So let's imagine that we want to build a program that finds a student that has the best GPA out of a group of students. Okay, so way to think about this, like kind of logically, right? We got a group of students, right? And we got a group of students, okay? And they all have different properties, right? We've got different names, and they've got different GPAs. Etc., right? And we want to find the student with the highest GPA. Okay. So let's take a look at an example that can do this based on what we've learned thus far. So let's take a look at this example. And one thing to note right from the get-go is that if your intuition is telling you that there's an easier way to do this, then your intuition is correct. There is. But we need to see a new topic to be able to see how to do that. Okay, but let's look at how we would do this based on what we've learned so far. And so far, one way of solving this is to use multiple arrays. So let's imagine we have a names array. Okay. So we've got our 5 students that are in that array. Okay, and then we have a GPA array. Okay, and a key thing to note is the way that we're having this built is that each index across multiple arrays is pertaining to a single student. Okay. Now you can imagine there can be other properties associated with what constitutes a student: an age, school year, first name, last name, all sorts of other properties that indicate what it means to be a student. But right now we're just looking at 2. Okay. And we've got this logic here where we're passing in the GPAs, right? Because it's an array, we need to know the size. We're keeping track of the location where we found the current top student and the current top GPA. And if we find another student that's higher than that GPA, then greater than the top GPA, then we're going to keep track of what that new top GPA is, as well as where we found it. And then we're going to return the location that has the top student, which in this case would be location 1. Okay. So now, and down here, right, we're printing out the top student is Beth. We do that, right, because this is going to, this here returns an integer as an index. Okay. And effectively then we're saying names and then that location, names 1, and that will give us the name Beth as the top student. Okay, so a couple of things to just note before we look at how we can kind of clean this up. Notice that names as every string is an array, right? So like the name Adam is an array. It's an array of characters, right? We have this 2-dimensional array because we effectively have multiple strings, an array of strings, okay? 5 strings. Each string can be a maximum of 16 characters. That would be 16 including the null terminator, right? Okay. So let's see how we can clean this up. And this is going to take into account how we're going to do this, as you would have guessed based on the name of this video, is we're going to use something called structures. Effectively, what structures are is it allows us to build our own custom data type. Okay, we're going to be able to build our own custom data type, right? We can give it a name, right? AKA like something like student. Right? And oftentimes we refer to these things, these custom data types, as things like composite types or aggregate data types, right? These are ones that we're building and they aggregate in a whole bunch of other data types, right? For instance, we could say, hey, well, we want a student to contain a name, right? So a string, right, for the name. We want the student to contain have a GPA and whatever else you might want in here, right? If you wanted to keep track of the student's age, whatever properties that belong to a, what we're defining as a student, right? We can go ahead and do that. So this idea of building data types, right? Building data types to simplify the code logic and encapsulate data that belongs together into a single unit or single variable is exceptionally powerful. Okay, so let's take a look at how we can change up this example using structures. Okay, and I'm going to show you a couple different ways of declaring and initializing a structure. And we're going to see that I'm then going to point to what I consider the easiest way to do it. It's actually not the only way, but I'll point to why I consider one particular style of doing it to be what I think is the easiest. So we define a structure. Here's an example defining a structure. It says, hey, we got structure student, right? It's going to contain, encapsulate in a name and a GPA. Okay, and we're going to do something. Here's the declaration. Right, so here's what we're really effectively defining the data type. Okay, here's where we declare a variable of that type. Okay, and then these lines are doing the initialization. Okay, these lines are doing the initialization here. Now I want to point out something. Notice I'm doing, the variable name is S. Name it whatever you want, obviously. And we're doing, to get at each member, right? We're going to refer to these as members of that structure. To get at each member, we're using something called dot notation, where I say, well, I want to get the name, right? So here we're initializing name to John. So I say s dot name, right? That gives me student s, right? Gives me access to this particular variable that's inside of the structure. Okay. We could also do s.gpa, gives me access to this particular variable inside that particular structure. Okay. Now, I'm going to show you multiple ways in which this is one way we can declare and initialize a structure, right? I'm going to show you a simpler one. Here we define the data type here, and it requires us to have this down here. We're going to see how we can kind of change this up a little bit to drop that as a requirement. And we can do that using something called typedef. That does what you would probably, as the name suggests, where we're defining a data type, right? You can do that, right? And let me tell you a bit about how we do that, right? Typedef says type definition. We're defining a data type, and we can give a data type a name that we kind of find useful. For example, here, unsigned char. Well, you may or may not remember, but what is the range, or how many bits does a char take? Well, it takes 8 bits or 1 byte, right? 8 bits or 1 byte. Okay, so you could, using typedef, give it a name, and this is a custom name. And I could say, hey, you know what? I just want to be able to declare something and say a variable of type byte. So I can in my code do something like that where I now have a variable, okay, that takes 8 bits to store. Okay, this is supposed to be a semicolon, not an I here. That takes 8 bits to store, aka, and I'm giving it a data type name that's kind of descriptive. It's 1 byte. It's 1 byte of data that we're storing, right? So we can do that. Okay, there's nothing wrong with doing that. And now that actually becomes useful because I could do something like this, where we're defining our structure here, okay, but I'm giving it a descriptive name, okay? So I'm giving it a descriptive name of the data type here, okay? And what I'm effectively doing is saying this structure that I've created, okay, usually I would have to declare it like this. If I gave it that name, I'd have to declare it using this as the data type, okay? But I'm assigning a new name here, okay? That allows me to say, hey, I want to declare something of type student, and I can declare it, that variable s of type student here, just say student s, just like any other variable, just like int x or double d or float f or whatever it happens to be. You're just saying the data. You're just saying the data type, right? Data type followed by the variable name. Okay, so it's a very, very easy way of using it, and that's okay. So what that does, right, when we're looking at typedef, is the big thing to kind of point out is it allowed us to, when we declared the variable, the structure variable, right, we no longer had to say struct student s, right, struct student s. It allowed me to just say student s. Okay, now it works either way, right? You do whatever you want. It's a style thing, right? Now, I told you before that I was going to give you what I consider my favorite way of doing this, and it would be doing the following. You can combine these into one definition, okay, where we're using typedef here, right? We're saying here is the type. We're defining a type. This is the type. We're building a type. This is the current type. Okay, this is the new name. And this is the definition of what it means to be of that type. So here's a student that has a first name, last name, age, gender. Okay, I could do it this way, right? Combine. I just think that's the easiest way is you define it all in one shot. Okay. Now I showed you those other steps so that you can kind of actually understand why it has this really weird syntax, right? We're defining a type. The type is, the original type is struct, and then whatever name that I wanted to give for it for the structure. This is what defines the structure, and then the nice, clean, descriptive name is here. Okay. And then I could say when I want to declare a student, I can say student s. Okay. Or student, whatever variable name I want. So then going back to the original thing, the original example, right? At the very beginning of this, I said our goal is we want to find a student with the best GPA in a group of students. So let's look at how this cleans up. And if you recall, right, without using structures, we saw this where we would have to keep track of multiple arrays and have things lined up nicely where the variables that associated with a single student, like the GPA, would be in one array and the name would be in another array, but they'd have the same index. Well, we could do it much easier, right? We could do something along these lines. Here I'm building an array of students, right? I'm building an array. I'm calling it roster, okay? Index 0, 1, 2, 3, and 4. And it's containing in each cell now, right? Each cell represents a student, okay? Each cell represents a student. Okay. So at any index, right, I find one student. In this case, that would be at roster index 1. Okay. Okay, so now what I didn't show you yet, this is the main method. I didn't show you everything that we use to define, like right now I'm using a function called makeStudent that initializes the student and then stores it in a roster. We'll take a look at that function. Okay, this is the main. So what we're seeing in that case, right, is the makeStudent function. I'm using it just as kind of like a helper function where we take in the name and the GPA, I declare a student, I initialize it, and I return it. Notice it returns type student. Okay, so each one of these function calls returns a type student, right? And we're going to store it as an array of students. And I just happen to give the name of that array as roster. Okay. Right, so notice how much easier that main method is. Okay, when we find the top student, right, we're going to, well, let's take a look at how that function works. Finding a top student, right, I can pass in the entire student roster, right? Notice it's an array of structures. And I'm searching, right? I'm first saying, hey, let's assume the top student is the first one in the array. Right? Let's assume the first student is Adam, is the best. Okay. And so we're going to say, assume that's the top student. Okay. Then we're going to iterate the rest of the array and we're going to see, is anybody else greater than the top student? So we get to Beth and we say, hey, well, Beth is a higher GPA. So then Beth becomes the top student, right? Beth is now the new top student. As we run through the rest of the array, there's no student that's better, right? So that becomes the student that's returned. And notice we're returning a student. We could do it just like any other data type. We can return the student, okay? And because this here returns type student, okay, I was using dot notation. It's kind of overwrote it here. There's a period here. Using dot notation to say dot get name, right? Because the student gives me this entire block, right? It gives me this entire block, this entire structure. I have to say that student dot in whatever variable I want. So if I want to then print the name, I have to say dot name. Okay, dot name. Okay, I'm going to stop it there. We'll get more practice using structures. Super helpful. And when we get into even another programming language, later on in the class, when we do Java and we do something called object-oriented programming, you're going to see that this idea of defining data types and using dot notation is something that comes up across multiple programming languages. So you will see it again.